Right. Hello, students. Today's lecture will be based on parallel lines and angles in parallel lines. Again, we have to some degree talked about parallel lines, and these are mathematical concepts that you'll be required to teach your children round about say grade 3, grade 4. We have already defined what a line is, and therefore we're now moving on to trying to understand that there are different types of lines that children can draw. And parallel lines are the ones that I've drawn here. In mathematics, we show that they're parallel if they have arrows like that. So, in other words, we cannot have a single line that is parallel. So, there has got to be more than one line for lines to be parallel. And there can be 3, 4, 5 or more lines that are parallel. But what we have to remember is that the definition of parallel lines is that this is a pair of lines or several lines whose distance apart is always the same. And in mathematics, we say that they are equidistant. And distant, meaning that the distance between them will always remain the same. The distance between the parallel lines will always remain the same. I'm trying to give two sets of parallel lines here because what I always see when teachers are teaching parallel lines is one single way of showing them like that. Try and show children that lines can be parallel facing in different directions. And there can also be several lines. They do not have to be only two. You can have 3. As long as they have arrows like that, this means this line is parallel to that one and that is parallel to that one, meaning they are equidistant. And also, it also therefore means the line, if this was A, is equidistant to B. That distance there will remain the same. Let me probably use another color. So that will remain the same, and that will remain the same. So we say they are equidistant. Now, this will be very, very short because I really expect you to know this, and try by all means to provide several illustrations in the classroom that shows children how parallel lines look like. For instance, if you are in a rural context, let me use a different pen, in a rural context where we probably have a rural house like that. Now you'd realize that would be a door and these would be sticks like that. And these guys that make these hats are so smart. They make sure that these sticks are parallel and they develop a certain pattern. And you'd find that the distance between this is the same and so on. They are equidistant. And that also goes for even when they are making the thatches, they are thatching the huts as well. The lines that they make, their distances between them are equal, and therefore they could be said to be parallel lines as well. And if you are in an urban context, you'll probably find most of the classrooms would have windows that have metals that are parallel. So these are several illustrations that you can provide to children to show what we mean by lines that are parallel. You can also provide examples of the edges of the desk. One edge is parallel to the other, but just be careful that it's not those that are the opposite edge. It's better to say that the opposite edges are parallel to each other, and so on. So try and provide various examples that show the children and enable them to understand what we mean by parallel lines. So that's a quick recap of that, and then I'll move on to angles that are formed within parallel lines. So if we had two parallel lines like that, and we cut those two lines by a line, this line is basically, we call it a transversal line. Transversal line. Transversal line. and these would be the parallel lines. Now, when two or more parallel lines are cut by a transversal line, there are always angles that are made between the parallel line and the transversal line. So this angle here, you would see that is equal to this angle there. And if, let's say, that was angle A and this was angle B, these are said to be corresponding angles. Corresponding angles. And corresponding angles are equal. Therefore, that means angle A is equal to angle B. Okay? Then that angle, therefore, there would also be equal to that angle there. That would be equal to that. They're on the same side of the transverse line against the two parallel lines, like that. Therefore, this angle here is equal to that angle, and these are said to be corresponding angles. And if we look at the angles inside as well, these ones here would correspond that to that angle there would also correspond to that angle. And that angle in there would also correspond to that angle in there. In fact, let me use a different color because they're not the same. So that angle would correspond to that angle as well. Now, since we're saying that corresponding angles are equal, that would mean the angles in yellow would be equal to each other. So if this was, say, let us say that was 65 degrees, this would also be 65 degrees. If that is 65 degrees, that would be also equal to 65 degrees. Therefore, we also have what we regard as angle on a straight line. Let me probably talk about that. Rather use. Here's a straight line. We did talk about this. We talked about an acute angle. We did talk about a right angle, which is 90 degrees. We talked about an obtuse angle, which is greater than 90 degrees, and a straight angle. The whole of that is 180 degrees. You remember we talked about that. Now, if we had two parallel lines like that, cut by a transversal line, that means this angle here would be regarded as a straight angle, which is would be regarded as a straight angle, which would be 180 degrees. Now, let's go back to what we're talking about. We had said this angle here was 65 degrees. Was 65 degrees. Now, if this is 65 degrees, this would also still be a straight line. Therefore, we can call that another straight angle. So if that is 65 degrees, we know that a straight angle is 180 degrees. We subtract 65 from 180. That would be 5. 6 from 7. 6, 5. 6 from 17 would be 85. Am I right? So then we know that that is a straight line. So if we subtract 65 from 180, okay, that would be, we'll be left with from 65 from 80, we're left with 15. Is that okay? 15 plus 100, so 115. Sorry. 115. 105 degrees. So that angle, therefore, there is 115. 115 degrees. So about my simple arithmetic there. So 115 degrees, therefore, is that angle. Now, we're talking about corresponding angles. So if that is 65, that would also be 65. If that is 115, that would also be 115, that angle there. Now, we talk about vertically opposite angles. Now, if we have any lines that cross each other like that, that angle there is vertically opposite to this angle. And this angle here would be vertically opposite to this angle. So any crossing angles that are developed at two crossing lines, the opposite angles are regarded as vertically opposite angles. And vertically opposite angles are equal. Vertically opposite angles. Vertically opposite angles are equal. So vertically opposite angles are equal. Now, so then if we go back to our diagram, we'd realize that this angle here is vertically opposite to that angle, and that is also vertically opposite to that. So let's start afresh. We have two lines crossing each other. The opposite angles are always the same, so that angle is equal to that angle, and that would be equal to that. And such angles are regarded as vertically opposite angles. Vertically opposite angles. Excuse my handwriting. So vertically opposite angles. Now, the knowledge of vertically opposite angles becomes very critical to your children, because they are going to use this knowledge to know that these are angles that are formed on lines that are made against two or more parallel lines with a transversal line. So, two parallel lines, again, always teach them to indicate that with these arrows. Otherwise, we would not know. Without these arrows, we can't conclude mathematically that these two lines are parallel. So that's one important symbol in mathematics that would show us that these lines are indeed parallel. So let's say they're cut by that transversal line. Already we can see that between this line and that line, at that crossing, vertical opposite angles are already developed. That angle is vertically opposite to that, and that angle is vertically opposite to that. Now, if we look very carefully, we can see that this line is parallel to that line, and therefore, that angle in there corresponds to that angle in there. Let me change the color. That angle in there corresponds to that angle in there, and that angle in there corresponds to that angle in there. The angle at the top, that corresponds to that angle there. And we had said corresponding angles are equal. Therefore, it means this angle is equal to that angle. It means this angle is equal to that angle. It means this angle is equal to that angle. Now, that is in terms of there being corresponding angles. corresponding angles. That relationship is derived from our knowledge that that angle corresponds to that angle, therefore it is equal. They are equal to each other. That angle corresponds to that angle, therefore these two angles are equal, and that angle corresponds to that angle, therefore these two angles are equal. Now, let's go back to our other relationship of vertically opposite angles. Which angles here are vertically opposite? We can see that the angle in red, that, in actual fact, is vertically opposite to that. So that angle can also acquire a red color. That angle is vertically opposite to that. Therefore, it can also acquire a red color. Why? Because we know that vertically opposite angles are equal. So if this angle was 110 degrees, that would also be 110 degrees. That would be 110 degrees, and that would be 110 degrees. Now, if that is 110, we can see that this line, that line, let me change. No. Let me change to that. That line is cut by that transversal line. Therefore, if this is my 110 degrees, that would be our 110. Now, because it's a straight line, there is our straight angle. So, if this is 110, the remaining angle there, we subtract 110 from 180, therefore this would be 70 degrees. Now, if this angle here is 70 degrees, it is vertically opposite to that angle there. Therefore, that angle should be 70 degrees. If that angle is 70 degrees, we can see that that angle against these two parallel lines cut by that transverse line, that angle is corresponding to that angle. So if it corresponds to that angle, that means that angle would also be 70 degrees. And from our knowledge of corresponding angles, we can see that that angle our knowledge of, not corresponding angles, but rather our knowledge of vertically opposite angles, we can see that that angle is vertically opposite to that angle there. So this angle here would also be 70 degrees. Now let us move on to a cleaner slate. We have our two parallel lines cut by a transverse line. This was 110 degrees, therefore this would also be 110 degrees. This is a straight line, 180. Therefore, if we know this to be 110, that would be 70 degrees. If that is 70 degrees, this would also be 70 degrees. Now we know that this angle here, let's not forget those arrows. We know that this angle here corresponds to that angle there. So that angle would be 70 degrees. But this angle is vertically opposite to that, so this would also be 70 degrees. But this angle here is vertically opposite to 110, so this would also be 110 degrees. But this angle corresponds to that angle there, so that angle would be 110 degrees. And it's very true because it is vertically opposite to that 110 degrees. So you can see the relationship between vertically opposite angles and corresponding angles formed by a transversal line that cuts two parallel lines and the various corresponding and vertically opposite angles that are made from these two parallel lines. Now let us look at another set of angles. We've talked about corresponding angles. And these would be two parallel lines cut by transverse, that corresponds to that, that corresponds to that, and even the inner ones, this one corresponds to that, and that corresponds to that. Okay? So that's that about corresponding angles. Then we've talked about vertically opposite. Vertically opposite angles. Now we have to remember corresponding angles are equal, and vertically opposite angles also are equal. So vertically opposite angles are formed at the cross of two lines. So that angle there is vertically opposite to this angle. Vertically opposite angles are equal, and that angle there is vertically opposite to that angle there. Okay? Now, the next set, therefore, is what are called alternate angles. Alternate angles are also formed at a set of parallel lines cut by a transversal line. This angle here would be said to be alternate to that angle there, and that angle there would be said to be alternate to that angle there. And alternate angles are equal. Angles are equal. That therefore means if this was 24, no, this is an obtuse angle. Therefore, let us say this was 120 degrees, that would also be 120 degrees. Now, from our knowledge of angles at a straight line, we know if this is 120 to complete all the way to there, from there to there is 120, all the way to there, therefore this would be 60 degrees. So if that is 60 degrees, it is alternate to that angle. That's why this one is also 60 degrees. And I think that explains the relationship on corresponding angles, vertically opposite angles, and alternate angles. Let's look at it from a fresh diagram. Again, let me probably 2 or even more parallel lines this time, cut by that transverse line. That angle there would correspond to that angle, and it would correspond to that angle. That angle there would correspond to that angle would correspond to that angle and correspond to that angle. That angle there would correspond to that angle and correspond to that angle. And we know, what about alternate angles? This angle would be alternate to that angle and vertically opposite to that angle. That angle would be that angle there would be alternate to that angle there. That angle there would be alternate to that angle there, and alternate angles are equal. So that angle would be equal to that angle. That angle would be equal to that angle. That angle is equal to that angle. One of the reasons is they are vertically opposite. So some of the questions, therefore, that can come out of this diagram would be, let us say we lettered this. Say A, use a different color. A, B, C, D, E, F, G, H, I, J. So we can be asked, what's the relationship? For instance, why, someone can ask, why is angle B equal to angle F? Angle B is equal to angle F because they are corresponding angles. Another question might be, why is angle A equal to, say, angle D? Why is angle A equal to angle D? Now we know that angle A corresponds with angle E, and angle E is vertically opposite to angle D. And vertically opposite angles are equal. So if D is equal to E, therefore, and E is equal to A, therefore A is equal to D. We might also be asked, why is angle, say, angle J equal to angle, why is angle J equal to angle B, for instance? Now, there is angle J and there is angle B. Either we can just take note of these two parallel lines and say angle J is alternate to angle B. Or we can say angle B corresponds to angle F, and angle F is alternate to angle J. That is also true. Or angle B corresponds to angle H. Yes, angle B there corresponds to angle H, which is vertically opposite to angle J. So there are several reasons that we can provide here to show how different angles are equal to each other. So that therefore summarizes our lecture for today on corresponding angles, vertically opposite angles, and alternate angles. So you need to define or draw corresponding angles, vertically opposite angles, and alternate angles from a set of parallel lines cut by a transversal line. Draw corresponding angles, vertically opposite angles, and alternate angles from a set of parallel lines cut by a transversal line. So that should be a good exercise, that you draw several, put in some figures showing different angles, and explain why angles are equal to each other and so on. The best ones would probably be that. These are corresponding angles A, B, C, D, E, F, G, H, I, J, K, L. So you need to show why some angles are equal to each other. Okay, thank you very much. Have a good day.